Cloud Spanner is a highly scalable, externally consistent, and globally distributed database. Creating an instance and connecting your application to it is fairly straightforward, providing an excellent troubleshooting experience for the database queries in an equally simpler sequence of steps is quite essential too. Last year, we launched Query Insights, which provides an easy way to quickly identify top queries by CPU utilization and analyze those queries in detail. But what if you want to compare execution plan for queries across instances? Today, we are excited to announce the preview launch of Query Plan Samples, a powerful visual tool for visualizing query plans for historical query executions. Not only does it let users to quickly visualize plans for selected queries, but also compare execution plans for instances of the same query, allowing developers and database administrators to quickly understand why their query is performing differently across different executions. Let's check it out with a quick demo. To access Cloud Spanner, go to Google Cloud Console and on the search bar, type Spanner. Once you select that, you should be able to see Google Cloud Spanner console. On the left, you see the Explorer pane, and on the right, you land on the Overview page. Before getting into Query Insights and Query Plan Samples details, let's first ensure that we have the instance, database, table, and data required for this demo. Let's take a look at the Query Insights for my application workload that's connected to an instance in Cloud Spanner. Query Insights dashboard helps users identify expensive queries by showing total CPU utilization for all queries, and for the selected database, listing top n queries and tags represented as graph and also in the form of a list. The top CPU utilization query that we see right here is the query that my application workload is running. So I'm going to click the fingerprint link to narrow down into the query details page. The query details page for the selected query displays execution count and average CPU in milliseconds, average latency in milliseconds, average rows returned, average rows scanned, and average bytes. And right below that is a new section that we have included now, which is Query Plan Samples. As you can see here, there are dots that represent the different points of execution of this same query that is under observation. The x-axis represents the time and the y-axis represents the latency. In our case, we can notice that at 4:13 p.m. the latency has been low, and at 4:16 p.m. it's increased to 696.26 milliseconds. This represents a dip in performance starting 4:16 p.m. Let's find out why. By clicking on a specific dot on this Query Plan Samples graph, we would be able to see the query plan on the right hand side of this page. And you can also expand it to a full screen mode. For the query execution at 4:13 p.m., we can notice that there has been an index scan. It has had a latency of 19.19 milliseconds. The same query at 4:16 has gone through a full table scan as opposed to the index scan on order item table and has had a latency of 642.27 milliseconds. This only means that the index IDX underscore price was suddenly dropped in between the two execution points of the same query. And Spanner is no longer able to use the index to quickly find the rows that match the query criteria. Instead, it has to perform a full table scan, which is a much slower operation. To fix the performance issue, I just have to create the index IDX underscore price back on the table. And Spanner can use the index to quickly find the rows that match the query again. And now in the query plan for the latest execution of the same query, we can notice that the performance of the query is back on track with an index scan low latency of about 19 milliseconds. As a developer, it helps for me to understand quickly why the same query performs differently at two different points of execution. It helps developers and database admins to quickly narrow down into the root cause of the issue and address it at the tip of their fingers. So why don't you try it out in your application today and find out why your application queries perform or behave differently at different points of execution. Use the link in the description to read more about it.